Most compost piles aren't failing because gardeners lack effort. They're failing because the biology inside the pile is being unintentionally suffocated. Many gardeners proudly build a compost heap believing they're creating black gold, only to end up with a smelly, stagnant mass that slows plant growth instead of feeding it. When compost smells like ammonia, rotting eggs, or swamp water, that's not decomposition, it's biological collapse. The fungal networks and aerobic microbes that build fertile soil are dying. On the Evergreen Garden channel, we focus on real soil biology, not gardening myths. So if you want compost that actually powers a living soil, subscribe to the channel and share your compost experiences in the comments, because the mistakes we're about to cover are far more common than most gardeners realize. The hidden cost of compost failure is the destruction of microbial life that soil depends on. A healthy compost pile is a living ecosystem. Billions of bacteria begin breaking down simple materials while fungal networks digest tougher carbon sources like wood and leaves. These organisms breathe oxygen, release heat, and transform waste into stable humus that feeds soil life for years. When the balance is right, compost piles naturally heat to around 130 to 150 degrees Fahrenheit, or about 55 to 65 degrees Celsius. That heat is not just a sign of decomposition, it's a sign that microbes are thriving. Beneficial bacteria multiply rapidly, fungi expand their networks, and the pile begins turning raw organic matter into plant-available nutrients. But when conditions collapse, usually because of incorrect ratios, lack of oxygen, or excess moisture, the biology changes completely. Aerobic microbes die off and are replaced by anaerobic bacteria. Instead of sweet, earthy compost, the pile begins producing ammonia, methane, and sulfur compounds. Nutrients volatilize into the air, and the microbial diversity that plants depend on disappears. What many gardeners don't realize is that a failed compost pile doesn't simply slow down decomposition. It can actively destroy microbial diversity and create material that suppresses plant growth when added to soil. Understanding the three most common mistakes is the difference between compost that feeds life and compost that kills it. Mistake number one is the carbon-to-nitrogen ratio that quietly suffocates microbial growth. The single most common reason compost fails is an imbalance between carbon-rich materials and nitrogen-rich materials. Microbes require carbon for energy and nitrogen for protein. When the ratio is wrong, microbial growth either explodes too quickly and collapses, or stalls completely. The ideal starting ratio for most compost piles is about 30 parts carbon to 1 part nitrogen. So let's talk about the materials you'll be adding to your compost. Carbon materials, often called browns, include dried leaves, straw, shredded cardboard, wood chips, and paper. On the other hand, nitrogen materials, known as greens, include grass clippings, vegetable scraps, coffee grounds, and fresh plant trimmings. Now, when nitrogen dominates the pile, microbes consume it rapidly and release excess nitrogen as ammonia gas. That sharp ammonia smell many gardeners notice is literally nutrients escaping into the air. A compost pile made entirely from fresh grass clippings is a classic example of this problem. Grass has a carbon-to-nitrogen ratio of roughly 17 to 1, which is far too nitrogen heavy. Without enough carbon to stabilize the process, the pile turns slimy and anaerobic within just a few days. On the other hand, a pile made almost entirely of dry leaves may sit for months without breaking down. Leaves often have ratios around 60 to 1 or higher, meaning microbes simply don't have enough nitrogen to multiply. A practical way to maintain the correct balance is by volume. For every bucket of kitchen scraps or grass clippings added to the pile, add roughly 2 to 3 buckets of carbon materials such as dried leaves, straw, or shredded cardboard. For example, if you add a gallon bucket of vegetable scraps from the kitchen, mix it with 2 gallons of dry leaves and 1 gallon of shredded cardboard. This simple adjustment brings the pile close to the ideal biological balance. Shredding carbon materials also speeds decomposition dramatically. Whole cardboard sheets or thick branches take years to break down, but when shredded into small pieces, they become microbial food almost immediately. Maintaining this balance allows bacteria and fungi to work together instead of competing for limited nutrients. Mistake number 2 is allowing oxygen to disappear and turning your compost pile into anaerobic sludge. Healthy compost breathes. Aerobic microbes require oxygen to perform the metabolic processes that break down organic matter. Without oxygen, decomposition shifts toward anaerobic bacteria that produce foul odors and toxic compounds. Air disappears from compost piles when materials become compacted or overly wet. Grass clippings, for example, naturally compress into dense layers that block airflow. Kitchen scraps can also form heavy pockets that trap moisture and eliminate oxygen. When oxygen disappears, microbial respiration changes almost immediately. Instead of producing heat and stable humus, the pile begins generating methane and hydrogen sulfide. These gases are responsible for the rotten egg smell that signals anaerobic decay. The solution is physical structure. A good compost pile contains coarse materials that create air channels. Small sticks, wood chips, and shredded stalks keep the pile from collapsing under its own weight. Turning the pile regularly also restores oxygen to deeper layers. For most backyard piles, turning every 7 to 10 days keeps the biology active. Each time the pile is turned, the cooler outer materials move into the hot microbial center, where decomposition accelerates. Gardeners who struggle with persistent anaerobic compost often see dramatic improvement simply by mixing coarse carbon materials into the pile. For instance, if a pile made mostly of food scraps and grass begins to smell, mix in several buckets of wood chips or shredded dry stalks and turn the entire pile thoroughly. Within days, the odor usually disappears as aerobic microbes regain control. The key principle is simple. Oxygen supports life. Without it, compost becomes biological decay rather than biological transformation. Mistake number 3 is moisture imbalance that drowns beneficial microbes. Water is essential for microbial activity, but too much water suffocates the organisms responsible for composting. A healthy compost pile should contain roughly 50 to 60% moisture. At this level, microbes have enough water to move nutrients through their cells while air pockets remain intact. When moisture climbs above this range, water fills the spaces that normally hold oxygen. Even a well-balanced compost pile can turn anaerobic if it becomes waterlogged. Many gardeners unintentionally create this problem by piling wet kitchen scraps into a heap without adding dry materials to absorb excess moisture. The simplest way to check moisture is the squeeze test. Grab a handful of compost and squeeze it firmly. If water drips out, the pile is too wet. If the material crumbles apart like dry dust, the pile is too dry. Ideally, it should feel like a wrung-out sponge, moist but not dripping. If a compost pile becomes soggy, the fastest solution is adding dry carbon materials. Shredded leaves, straw, sawdust, or cardboard absorb excess moisture while restoring airflow. For example, if your pile has become wet after heavy rain or large amounts of kitchen waste, mix in 2 or 3 large bags of dry leaves and turn the pile thoroughly. This immediately restores the moisture balance. On the other hand, extremely dry piles often occur in hot climates or during long periods without rain. In these cases, watering the pile lightly while turning it can restart microbial activity. Water should be added gradually, while mixing until the pile reaches that wrung-out sponge texture. Maintaining the correct moisture level allows microbes to remain active without drowning the oxygen they require. Healthy compost is not about waste management, but about building a living soil ecosystem. When these 3 factors, carbon ratio, oxygen, and moisture, are balanced, compost becomes one of the most powerful tools a gardener can use. Instead of producing a smelly pile that struggles to break down, the compost transforms into a biologically active material rich with bacteria, fungi, protozoa, and beneficial nematodes. These organisms continue working long after the compost is applied to soil. Fungal networks extend through the soil profile, transporting nutrients to plant roots. Bacteria release nitrogen and phosphorus in plant-available forms. Organic matter improves soil structure, allowing roots to penetrate deeper and retain moisture during dry periods. Gardeners who fix these three compost mistakes often notice the difference within a single growing season. Plants grow more vigorously, soil becomes darker and crumbly, and the entire garden ecosystem begins supporting itself. Composting is not complicated, but it is biological. Once the conditions for microbial life are understood and maintained, the process becomes reliable and predictable. Compost succeeds when gardeners work with microbial biology instead of against it. The biggest shift in composting happens when gardeners stop thinking of compost piles as garbage heaps and start seeing them as microbial habitats. Every bucket of leaves added to the pile feeds carbon-hungry fungi. Every handful of kitchen scrap supplies nitrogen that bacteria require to multiply. Turning the pile restores oxygen, so those organisms can breathe. Balancing moisture ensures they remain active without suffocating. When those conditions are right, composting becomes effortless. Microbes handle the work, heat builds naturally, and the pile gradually transforms into stable humus that strengthens soil year after year. That's the real goal of composting, not simply breaking down waste, but cultivating the living organisms that make soil fertile. If you found this guide helpful and want more serious, biology-driven gardening advice, make sure to subscribe to the Evergreen Garden channel and share this video with fellow gardeners who want healthier soil. And drop a comment below describing your compost setup or the challenges you've faced, because the best gardens are built by growers who keep learning from each other.